All right, good morning, Algebra 2. Today we're going to start talking about log functions as exponential inverses. We're going to split this over 2 days. We've been talking about exponential functions, and so we're going to take those and change them into log functions. This is a concept that we're going to be using, so we need to get a really good, deep understanding. So, we're going to start by reminding you that an exponential function was always in this form y equals, and I said a, but remember a was your stretch or compress, b to the x. So we're going to switch this into what we call a logarithmic function. All right. A log function, as we say, takes these same variables and we move them around. It's going to sit in the form log. The base to the exponent is the base of our log. It's a little tiny b at the bottom. And then y, so what this equals, is equal to its exponent. So a log function moves things around and makes it equal to the exponent of the base. All right. So the real reason we want to do this is we want to be able to change it from one form to another. Same numbers, same everything, just switching them in one form. So if we have something that looks like this, 16 equals y squared. Well, we know this is true, right? This is our y equals, this is our b to the x. We're going to rewrite this in log form. So if we have a log, the base to our exponent is 4, so we have a little 4 at the base of our log. This whole thing equals 16, so that comes next. And this equals its exponent, in this case, 2. We can also write that with maybe the base and exponent on the left-hand side. So let's say we have 2 to the third equals 8. Again, this is b to the x equals y. We've just moved the y to the right-hand side. Again, rewriting this in log form, we have log. The base to the exponent is 2, so it's a little 2 here. This whole thing equals, or the y value is 8, and this equals the exponent of 3. So let's do some examples. This is going to be the first third of your worksheet today, is being able to switch these from exponential form into log form. So example number 1 today. Write each equation in log form. All right. So let's start off with some basic ones. This is exactly what the first problems on your worksheet will look like. So let's say I have 5 to the third equals 125. I want to rewrite this in log form. Again, I want to remind you, this is our b, the exponent is always x, and this equals our y. So putting this in log form, we have log. The base is b, which in this case is 5. Our y value is 125, and this equals 3, the exponent. Let's try another one. Example number 2. We have 4 to the 5th power equals 1,024. So again, quick reminder, this is b to the x equals y. Let's rewrite this in log form. We have log, the base to our exponent is 4. This equals 1,024, and our log will equal the exponent of 5. If you have your graphing calculator, you can type in log base 4, 1024, and this equals 5. You will find the log base in the math portion in your calculator. Let's try another one. Let's get it just a little bit tougher today. How about example number 3? Let's say we have 1/3 raised to the exponent of -3 equals 27. Again, this is a true statement. Remember that a negative exponent flips this. So this is really 3 to the 3rd power, or 27. We're still going to rewrite it like this in log form. Again, this is still our b. This is still our exponent. And of course, this equals y. Writing it in log form, we have log, the base to our exponent is 1/3. It equals 27, and our log equals the exponent of -3. Now, the whole idea is that we can actually write this in the other direction. All right, so as I said, we can also write this going in the other direction. So we're actually going to go from log base b of x equals y, and we're going to switch this into exponential form, b to the x. Sorry, I wrote this incorrectly. Let's try that again. My bad. Log base b of y equals x is the same as the inverse of b to the x equals y. My apologies for that. Getting ahead of myself. So, in the next portion on our worksheet today, we're going to do example 4. It's going to say write each equation in exponential form. So if I have log base 7 of 49 equals 2, I need to rewrite this in exponential form. Remember, this is log base b of y equals x. So let's write this in exponential form. So we have our base, which is 7, our x is our exponent, 2, equals 49. And we know this is a true statement, right? 7 squared equals 49. Try another one. Example 5. We have the log base b of 5, 1 equals 0. We're going to rewrite this in exponential form. Again, quick reminder, this is our b, this is our y, and this is our x. So rewriting this as b to the x, which is 0, equals 1. Again, is this true? Yes. Anything raised to the 0 power equals 1. Let's try one just a little bit tougher. Example 6. All right, we have log base 8 of 1 over 64 equals -2. Again, a reminder that this is log base b of x of y, excuse me, it's the second time I've said that today, of y equals x, our exponent. We're going to write this in exponential form, which is b to the x equals y. So in this case, our b is 8, our exponent is the -2, and our y value is 1 over 64. Again, this is a true statement. A negative exponent would move this 8 to the denominator and square it. We would get 1 over 64. All right, so why is this important to be able to do? Let's talk about that. So being able to write something from log form into exponential or from exponential into log provides us two different things. The first thing it does is it helps us to evaluate a log without a calculator. The second thing it's going to allow us to do is to solve equations involving either log or exponential. Today we're going to focus on the first one. We're going to talk about how to evaluate a log without a calculator. So, to evaluate, all right, 1, I'm going to ask you to set it equal to x. 2, I want you to write it in exponential form. 3, determine a similar base. Four. You want to write each side with the same base. Step 5. Once you have those bases the same, you're going to set your exponents equal to each other. This is called a one-to-one function. And then step 6, solve for the unknown. So this is the last portion of your worksheet today. And let's begin with our first example. Let's see how these steps go into play. So here's example 7. I'm going to ask you to evaluate each log. And again, I'm looking for these steps. I know you can type it into a calculator. That's not what I want. I want to see these steps because we're going to be able to, or we're going to need to use these steps in the future to solve equations, which your calculator can't help you with. So if you are given, let's say, log base 2 of 16. Step 1, I'm going to ask you to take this log, base 2 of 16, and set it equal to x. All right, so that's step 1. Step 2, I'm going to ask that you write this in exponential form. So this would be the base 2 to the exponent of x equals 16. Step 3, determine what base they both have in common. Well, this side, you can't go any smaller than 2. 16, if I had 16, 16 is 4 times 4, and 4 is 2 and 2, and of course 2 and 2. So we know that 16 can be written as 2 to the 4th power. So this side stays the same, 2 to the x. Over here we have 2 to the 4th power. Now that the bases are the same, we can go ahead and set these exponents equal to each other. So we have x equals 4. Again, this is a one-to-one function. Now, technically, when we determined by our steps up here, we determined that the base was 2. This actually was steps 2 and 3, right, determining the same base. And then this would be step 4, and then, of course, 5. And do we have anything to solve? Of course not. Let's try another one. Example number 8. If I have the log base 4 of 64. All right. So first we're going to take this and set it equal to x. Second, we're going to set this in or rewrite it in exponential form. This is 4 to the x equals 64. All right. Now we determine what base they have in common. Well, 64 can break down into a base of 4, which is 16 times 4, and 16 is 4 and 4. So on this side, we have 4 to the 3rd power equals 64. And this side is 4 to the x. Again, now that the bases are the same, we can set these exponents equal to each other. 3 of x equals 3. Now I do want to talk about the fact that this can break down further. Alright, so this is 1 as soon as you found that the base was 4. Let's talk about what if the base wasn't 4? What if we came up with something different? So for example, 4 breaks down into 2 and 2, and we have 2 and 2 here, and we have 2 and 2 here. So on this side, we determine that the base could be 2 to the 1, 2, 3, 4, 5, 6 power. Alright, so if this side happened to be 2 to the 6th power, we would have to write this 4 also as a base of 2. 4 is 2 squared. And again, we already have the exponent of x there, so we're going to carry that down. Now we have the same base as 2. We can set our exponents equal to each other. So we have 2x equals 6. Solving this equation, dividing both sides by 2, we also find out that x equals 3. So as long as your bases are the same, you can compare your exponents, and you'll get the same answer. Let's try another one. Let's get a little bit tougher today. Example number 9. So we have the log base 9 of 27. This is a perfect example of what I was just talking about. So, step 1, we're going to set this equal to x. Again, that x represents the exponent. Step 2, we're going to rewrite it in exponential form. We have 9 to the x equals 27. We know that 27 does not have a base of 9. It's 9 times 3, but 9 breaks down into 3 and 3. So on our right-hand side, the only base that has an exponent that will come to 27 is 3. 3 to the third power. Well, 9 has to be rewritten. 9 is also 3 squared. And again, we're going to bring that x down in our exponent. Now that the bases are the same, we can set our exponents equal to each other. We have 2x equals 3. Solving this equation, we're going to divide both sides by 2, and x equals 3/2. If you were to type this in your calculator, you will get 1.5. Or if you hit math enter, 3/2. However, these steps are the critical ones that we are going to be using in the future. So, example number 10. This will be our last one today. This one's a little special, so I want to point it out. On example 10, we have log base 2 of negative 64. So again, first thing we want to do is take this and set it equal to x. Okay, let's rewrite this in exponential form. That's 2 to the x equals negative 64. Is there ever a time where a positive number raised to an exponent can equal a negative number? Absolutely not. So this is no solution. I would like to point out that you can never, ever, ever have a negative number behind the log. So right away, we knew this was impossible because you can't have a log of a negative number. And again, this would be no solution. So let's practice these today with your worksheet. I do want to point out that there is a typo on your worksheet. Again, I apologize for that. So, real quick, on number 8 on the worksheet. It should be 10 to the negative 3 equals 0.001. Okay? Accidentally, I typed a 2 instead of a negative there. I apologize for that. So please make that correction on your worksheet, and then you are going to be rewriting this in log form. If you have any questions, let me know. Good luck, you guys.